Hello game developers and welcome back to Let's Make Pong. This is episode 7. Last episode we got done implementing collision with our paddles. This episode we're going to look at implementing game state using a very simple implementation of a state machine. We're going to talk a little bit about what that is. Before we get started, go over some of the code changes I did in between episodes. One of the first things I did is I took some of the constant numbers we're using and I put them up here into static final floats just to act as constant variables we can use throughout the program. That way, if we use, say, ball max speed in multiple places, we don't have to, and we decide 650 is not what we want, we can just change it here, and instead of having to go through and change it in multiple places, right? So we have ball max speed, which we're not using yet, but we will get to using. We have ball reflect angle, which is the angle, the minimum and maximum angle that the ball can reflect off the paddle. We have ball velocity, which is its starting velocity. We have the velocity modifier for the ball, which is how much velocity it gains when it collides with a paddle. And then we have paddle velocity, which is how fast up and down the paddles can move. Alright, so what is a state machine? Really at its core, it's just a collection of states that an object can be in, with code that it can run in those states, and methods to take input and change state. Okay? So a very simple example of a state machine is a light switch. It has an on state and an off state, and it can take the input of flipping the switch to change that state, right? So if it's an off and you flip the switch, it's now on. If it's on and you flip it, it's now off. That's a state machine. Game-wise, a good example is, say, a guard NPC in almost any RPG. It may have something like a patrol state, and while it's in that state, it just wanders around the castle, looking for players, walking, avoiding obstacles, whatever. And say it has an input of it sees a player. So it'll see the player and transition to a attack player state. Now in that state, it'll go forward, try to attack the player, try to kill him. Now say the NPC's health gets too low. Then it can transition to a flee or a runaway state, where it'll run away, attempt to hide, regain some health. Now say it gains some health back, it doesn't see a player nearby, so it transitions back to a patrol state, and it all starts again, right? So that's an AI state machine. What we're going to be doing is a game state machine. It's states that our game can be in and ways to transition between that. So for our purposes, we're going to have a new game state. That's going to be where the game is brand new. It's going to reset the score, reset the positions of the balls and paddle, or the ball and paddles, and then transition into the play state. The reset state will be similar, except it won't reset the scores. And then the play state is what we have going on in the game now, where the ball moves, we interact with it with the paddle, and play the game. So very simple. Now, you can implement state machines in a variety of ways. Like you could have a single governing object, say called state machine, and then you have an abstract class called state. Then you have your specific state you want to implement, say patrol or attack player or flee, that you would extend from state, implement your logic, and then pass those into the state machine on the NPC guard, for instance. Can get pretty complicated if you wanted to, but what we're going to do is we're going to use an enumeration to represent our states, and then we're going to use a switch statement to represent our state machine. So we're going to do a switch on the current state. Depending on which one it is, we'll run code specific to that state, and that's pretty much it. So first thing we need to do is make our enumeration. We'll just call it game state, and we'll have new, reset, and play. And then we'll need a current state, so we'll know what the state currently is that we're in. And we'll start it out in game state new. Straightforward. Now we'll jump down here to the update method. And the update method is where we're going to implement our state machine, right? It's going to be a switch statement on the current state. We'll just implement those automatically. And so this says, if the current state is new, run this code. If the current state is reset, run this code. And if the current state is play, run this code. So if it's new, we need to reset the score, reset the position of everything, and then move into the play state. So we're going to make a new game method. This is just some pre-planning here, because all it's going to do for now is reset the score, which we don't have yet, so we'll go up here and make that real quick. Right, so now we have score 1 and score 2, which will be for player 1 and player 2 respectively. Okay, so new game resets the score. We already have a reset method, which resets everything for us. And then we want to transition into the play state, so we just do current state equals game state dot play, and that's it. That's the new state. The play state, very simple. We already have it implemented. Just copy and paste. So play state, update the ball, update the paddles, same thing we've been doing. And then the reset state, it's just going to call reset. It's going to leave the score alone, and then it'll transition into the play state. Just refactor, rearrange the code there. All right, now say we're in the play state and we want to start a new game, right? Player 1's just beating player 2 too badly. Player 2 wants to give up and start again. So we need to give them a way to do that other than stopping the application and starting it back up. So we're going to handle some input. We'll just do handle input in the play state here. And what we're going to do is say if a player hits the N key on the keyboard, it's going to start a new game. And to do that now, all we have to do is set the current state to new. So the next time this update happens, right? So you're in play now. They hit N here. It'll set the state to new. This frame will finish. Update will be called again. And now the state is new, so it'll call new game, reset, and then go back to play. So we do get the key press, just like we did with our paddles. And we'll do N for now. And all we have to do is say current state equals game state new. And we'll also give them a way to exit the application other than closing the window, just for nicety's sake. Same way, can't type. Alright, so if they hit the escape key, then we're going to close out of the game. And to do that, we can access the application interface here through the GDX class, just app. And on here it has a whole bunch of things, which we will look at in other episodes or other games, but the one we want is exit. And then this will call your dispose method, hidden in here somewhere, right? Yep, there. It'll call the dispose method of your application listener, and then close out the game. So that's all that's needed there. Alright, so we have our new state, reset state, and play state set up. So let's take a look. Oh, that's just a mistake on my end. Something I was working with earlier. We will come back to this. There we go. Let's try that again. There we go. Alright, so the game's playing, just like normal. Alright, so let's hit N, see what happens. We should reset everything. Yep. Everything gets set back to normal, as we would expect. And if we hit escape, everything closes out. So far, so good. Alright, and here, instead of calling reset when create is called. We can just call new game and reset. This way, right now it just resets the score, which is kind of redundant, but later on, setting up a new game may do more for us. So we want to call that just in case. And yeah, feel pretty good about this. I think we'll go ahead and stop here. Next episode, we'll look at getting the score up on the screen. We'll have to talk about bitmap fonts. We'll talk about assets and file loading in that episode. Then after that, we will set up scoring so that the hitting the sides actually scores a point for you. We'll do some final code cleanup, like limiting how fast the ball can go, messing around with the size of the screen and how big the paddle and the balls are. And then we'll be almost done. So thank you for joining me.